Hey guys, my name is IBM and I am solving 9702 paper 1-3. This is multiple choice questions and it is supposed to be 1 hour and 15 minutes. So I will not go through the instructions because they are the usual instructions. You can go through them. You can go through the data given. I'll go straight to question number 1. So what is equal to 0.00005 joules. So 0.005 joules. So we have this is in milli, this is in mega, this is in micro, this is in nanojoules. So this one is the same as 5. Milli is 10 to the power of minus 3. So this is 0.005. So this is out. Mega is of course going to be 5 times 10 to the power of 6 joules. So this is out because the power is positive. This is 5 times 10 to the power of minus 6 joules. So this is 1, 2, 3, 4, 5, 6. So the answer is going to be C. So that is 5 times 10 to the power of minus 6, which is the answer to that question. So the measurement of a physical quantity may be, of course, remember nano is times 10 to the power of minus 9, which is going to be having more zeros there. The measurement of physical quantity may be subject to random errors and to systematic errors. Which statement is correct? So we know a systematic error makes all readings to deviate from the true value by a constant amount in one direction. And a random error makes values to scatter around. So for random, the values are going to scatter. And this one, for systematic, the values deviate in one direction with a constant amount. So a systematic error cannot be reduced by adjusting the apparatus. This cannot reduce a systematic error. A systematic error results in different readings each time. The readings, each time the measurement taken, the readings could be deviating by the same amount. Random errors are always caused by a person taking the measurements. Random errors are caused by taking measurements from different angles, taking measurements or wrong interpolation or wrong calibration. Wrong interpolation and taking measurements from different angles. Systematic errors are caused by wrong calibration, zero error in the instrument. The random errors can be reduced by taking the average of several measurements. So the question is, which statement is correct? The random errors can be reduced by taking the average of measurements. Random errors are always caused by a person taking the measurements. Systematic errors results in a different reading each time the measurement is taken. I think this is, I have to look at this again. So which statement is correct? A systematic error cannot be reduced by adjusting the apparatus. Of course, adjusting the apparatus cannot reduce a systematic error. If the apparatus is wrongly calibrated, or if there is a zero error, even if you adjust the apparatus, as long as there is a zero error, there will be still a systematic error. Systematic error results in a different reading each time. That is not true. Systematic error will result into all measurements to deviate by constant amount. Random errors are always caused by the person taking the measurement. So this is true. Random errors are going to depend on, random errors are always caused by the person taking the measurement. So this is not true because if there is random errors are not necessarily caused by the person taking measurements, but they are always going to be there. For example, if there is wrong interpolation, because wrong interpolation depends on the judgment, if you take measurements from different angles, but random errors can be reduced by taking the average of several measurements. Of course, this is the correct answer to this question. So random errors, by taking measurements, if for example you're measuring the diameter and you take measurements at different points around the object and you obtain the average, then you minimize or you reduce random errors. The Young modulus of a material of a wire is to be found. The Young modulus E is given by the equation E is equal to 4FL over pi d squared x. The wire is extended by a known force and the following measurements are made. Which measurement has the largest effect on the uncertainty? So to find the effects of these uncertainties, I will find their fraction uncertainties first. So because the fraction uncertainty in E is going to be, we ignore 4, we ignore pi, so we shall have the fraction uncertainty in F plus the fraction uncertainty in L plus twice the fraction uncertainty in D, then plus the fraction uncertainty in X. Of course, this 2 is because D was squared. So we can just press our calculators to check these fractions and see which one is bigger. So for F, the fraction uncertainty is going to be 0.01 divided by 19.62. So that is 5.1 times 10 to the power of minus 3. So minus 4. That is the fraction uncertainty. Then for L, the fraction uncertainty, the effect on the absolute uncertainty for E is going to be 0.002 divided by 2.04. 0.002 divided by 2.043. So that is 9.8 times 10 to the power of minus 4. 9.8 times 10 to the power of minus 4. We want the one with the largest effect, remember. Then for D, the effect for D, we can look at the fraction uncertainty is 2 times delta D over D. So it is 2 times the absolute in D, which is 0.02 divided by 0.54. So this is giving us 0.74. Sorry, 0.074. Then for X, its contribution is 0.2 divided by 5.2, 0.038. 0.038. So for X is 0.038. So we notice that D was the biggest, was giving the biggest contribution, which was 0.074. So the answer is going to be B. Two physical quantities combined together as a product can produce a scalar quantity. Which product of two quantities produces a scalar quantity? So force is a vector quantity, displacement is a vector quantity. This one is the same as work, and work is a scalar quantity. Mass times acceleration. This one gives us force, which is a vector. Pressure times area. Of course, this also gives us force because pressure is force acting normally per area. So this one is equal to force. So that is a vector. Velocity times time for which an object has that velocity. Velocity times the time for which the object has that velocity. So that is, I think that is displacement. Displacement is the velocity times the time. So this is equal to displacement, which is a vector quantity. So the answer is A. The diagram shows a velocity time graph for an object moving in a straight line. What is the displacement during the last 2 seconds? The last 2 seconds. So from here up to these are 2 seconds. So the displacement is the area under this part here. So the displacement is equal to the area under that part, or area under the graph. So you can take it as a trapezium where this is going to be 6, this will be 12, and this will be 2. So the displacement, or I can take the bigger triangle minus the smaller triangle. So this is going to be a half times the bigger triangle. The area of the bigger triangle is the one I'm starting with. So that is 4 times 12 minus a half times the area of the small triangle is 2 times 6. So this is going to be 2 times, that is 24 minus 6, which I think is going to be 18 meters. So the answer here is going to be C. A block is moving along a horizontal frictionless surface. So there's no friction. A constant force F. So F is a constant force and a constant resistive force of 5 newtons act on the block as it is moving in the direction of the force. So a constant resistive force of 5 newtons acts on the block as it is moving in the direction of the force. So the block is moving in this direction. So direction of motion is in that direction. So a body moves in the direction of, if there's a resultant force in the direction of the motion, then the body must be moving in the same direction as the resultant force. So how do we find the resultant force on this body? So the resultant force is given by, remember, it is given by a mass times acceleration. Oh, the resultant force is the same as the rate of change of momentum, which is change in momentum divided by t. But what is the resultant force? The resultant force, because the motion is to the right, I will assume the resultant maybe is to the right. So the resultant force is going to be F minus 5, should be equal to the rate of change of momentum, which will be change in momentum over t. That is the resultant force. So the question is, the graph shows the variation with the time t of the momentum of the block. What is the magnitude of the momentum of the block? And this is a graph of momentum against time. And the graph of change in momentum against time, the gradient is giving us the resultant force. So since the resultant force, F resultant, is equal to the gradient. So the resultant force is the gradient of this graph, which is going to be 2.7 minus 1.5 divided by 0 minus 0.4. And this is going to give us the gradient is the resultant force, which is the rate of change of momentum, whether this is equal to the gradient. So this is going to be 2.7 minus 1.5 divided by negative 0.4. So the answer here is going to be negative 3.0. That is the gradient, but the gradient is the rate of change of change in momentum over t is the gradient, which is force, or the resultant force. So I will say F minus 5 is equal to negative 3.0. So F is going to be equal to 5 minus 3.0, which is equal to 2.0 newtons. So F is 2.0 newtons, which makes the answer to be A. Newton's third law describes two forces that are equal in magnitude and form a pair. They're equal in magnitude and form a pair. That is Newton's third law. Remember Newton's third law, whenever you have two bodies in contact, A and B, the force on A caused by B is equal but opposed to the force on B caused by A. The forces are equal and in opposite directions. They are equal in magnitude and in opposite directions. So which description of the two forces in such a pair is not correct? One, they act in opposite directions. I think that is correct. Two, they act on two different bodies. I think that one is also correct. They act on two different bodies. Three, the forces are of the same type, which I also think the forces should be of the same kind. And that means the answer is going to be D. They cause an object to be in equilibrium. So these forces are not enough to cause an object to be in equilibrium because these two forces could be equal but and opposite. They could be cancelling out each other, but they could be causing clockwise or anti-clockwise moments. So the resultant force is zero, but the resultant moment is not. We don't know whether it is zero or not. So this statement here, they cause an object to be in equilibrium, may not be correct because not all objects under the action of these forces have no moment. The graph shows the variation with the time of the speed of a rainy drop falling vertically through air. What statement is correct? So remember the speed time graph or the velocity time graph, the gradient is the acceleration. Gradient equals to the acceleration. Because the line is becoming horizontal, we see that the acceleration is decreasing. So the acceleration is decreasing, and at this point here, where we have reached terminal velocity, the acceleration is zero when the line becomes horizontal. So which statement is correct? The acceleration decreases to produce a steady speed. Of course, I think the answer is automatically going to be A. Because the gradient is decreasing, the acceleration is decreasing, and at the point where the line becomes horizontal, the gradient has become horizontal, the acceleration is equal to zero. Remember, the gradient is the acceleration. So the answer is automatically A. Which statement about a perfectly elastic collision between two objects is correct? Perfectly elastic. Of course, for both collisions, whether elastic or inelastic, momentum is always conserved. But for elastic, kinetic energy is also conserved. So this means we have to look for an answer which has kinetic energy being conserved. Total kinetic energy is conserved, which is true. The relative speed of approach equals the relative speed of separation. So the answer is A. Because if the relative speed of approach equals the relative speed of separation, it means total kinetic energy before collision is the same as total kinetic energy after collision. So I don't need to inspect the rest because the first one is just making good sense. So the answer is A. The diagram shows the view from above of a sprinkler system used to water a garden. The sprinkler consists of a tube of length. So the length of the tube is 0.15 meters. The tube is pivoted in the middle and spins in a horizontal plane as lets out it lets out jets of water from each end. The two water jets are in opposite direction to each other. Each water jet exerts a horizontal force of 3 newtons on the tube at right angles to the tube. What is the magnitude of the torque from the tube? So these ones are causing, I think they are causing anticlockwise moment about the pivot. So the torque is equal to the product of, because these are two forces, to be the product of one of the forces. The torque is just going to be the total moment, which is going to be called the product of one of the forces and the perpendicular distance between them, d between them. So one of the forces is 3 newtons and the perpendicular distance between them is 0.15. So the torque we are looking for is simply 3.0 times 0.15. 3.0 times 0.15. which gives us 0.45. So the answer is C, 0.45 Newton meters. So number 10, the answer is C. An object is held in equilibrium by three forces. The forces all act in the same plane. The diagram shows two of the forces that act on the object. The third force is missing from the diagram. What is the third force? So the third force should be such that it cancels out the resultant of these two. So let's first find the resultant of these two using the parallelogram rule. So by the parallelogram rule, I will draw 43 newtons here, and I will draw 17 newtons here. So this is 17 newtons without changing the direction, and this is 43 newtons without changing the direction. The resultant of these two forces is going to be a force which is here. So the resultant of these two is a force which points in that direction. So if there is no force to counter this one, then the body must move in that direction of the two arrows. So the force we are looking for, which will cancel out that one, should be a force acting in the same line but in the opposite direction. So this is the third force we are looking for, which cancels out the resultant, which is in that direction. So the third force must be approximately pointing that side. So when we look at the diagrams here, so we have this one is the resultant of those two, so it's not correct. C points the other side is not correct. D points that side is not correct. So the answer is automatically B. If you want to check the magnitude, you can also check the magnitude and see whether it is the magnitude is correct. So the magnitude of that force is the same as this one here, where if this is 125, this angle is also 125, making this angle to be 55, I think. This angle should also be 55 degrees. So if I want to find the resultant using the cosine rule very fast, r squared will be equal to 17 squared plus 43 squared, then minus 2 times 17 times 43 cos of 55. And I think when you find the square root, the answer should be approximately 36 newtons. So the magnitude should be 36 newtons. I don't need to check the angle. But if you want to check also the angle, I think you can still do that. So the angle we are looking for is this angle here. This is the angle we are looking for. So remember, this is a straight line. This is 55. I think you should be able to find this angle. Alternatively, you can prolong this and predict what this angle is going to be and what this angle is. So precisely that will be, I think it is going to be 157. I'll not be able to show that because it's not part of the question. Total number of forces acting on an object is 2. The object is in equilibrium. Which statement about the forces are correct? So if there are only 2 and the object is in equilibrium, then these two forces must be equal in magnitude. That is number 1. They must be acting in opposite directions. The two forces must act in the same direction. But they say the object is in equilibrium. If they act in the same direction, this cannot give us a resultant as 0. Because remember, for the body to be in equilibrium, the resultant force should be 0 and the resultant torque should also be 0. The two forces must act through the same point. If they act through the same point, then they have no moment about any given point. So if one force acts there and another one acts in that direction and they are equal in magnitude, none of them causes a resultant moment. So it means this is also going to be true. So the answer is going to be 1 and 3, which makes the answer to be B. The diagram shows the arrangement of 2 atoms in a particular crystal. Each atom is at the corner of a cube. What is the shortest distance? What is the shortest distance between the centers of 2 adjacent atoms? So we want the shortest distance between the centers of two adjacent atoms. So we know that I'll use this space here. Volume, I think volume is mass divided by density, and the volume is simply going to be the mass of an atom, which is 3.5 times 10 to the power of minus 25 divided by the density, which is 9.2 times 10 to the power of 3. So I think this would give us the volume, which would be equal to 3.5 exponent minus 25 divided by 9.2 exponent 3. So this is 3.80 times 10 to the power of minus 29. 3.80 times 10 to the power of minus 29. This is going to be meters cubed for the volume. Then because this is a cube, then one side of the cube is going to be equal to the cube root of the volume. So that is 3.80 times 10 to the power of minus 9. So this gives us the cube root. So I'll just say shift cube root of the answer, which is 3.36. 3.36 times 3.36 times 10 to the power of minus 10 meters. Okay, because this is just an estimate, and we have even rounded off this. This can be rounded off to 3.4 times 10 to the power of minus 10 meters, because this is a very small distance. The distance between the length of the side of the cube is going to be approximately equal to the distance between the centers of the cube, because the power of 10 is going to be approximately the same. So the power of 10 you just look at the power of 10, you don't need to look at this value here. The power of 10 must be approximately of the same order as the diameter of an atom, or the diameter or the radius of an atom. So this is going to give us the answer to be C. 4 measuring cylinders are filled with the same liquid to the heights shown. At which position is the pressure greatest? Remember, pressure in a liquid is equal to density times d times height, where h is the height of the liquid above. So here the pressure here is going to be density times g times 0.3. Here the pressure is going to be density times g times the height of the liquid above point B, which is 30 minus 10. This height is going to be 20. So this is going to be times 0.2. Oh, sorry, this was at the surface, so the height here was 0. So this is times 0. So here the pressure due to the liquid is 0. Oh, it is just 0 plus atmospheric pressure. Then here, the pressure at that point, total pressure is going to be equal to atmospheric pressure plus density times g times 0.2. Then here it is just atmospheric pressure. Pressure is equal to simply atmospheric, that is at C. Then here, the pressure is going to be the pressure due to the atmosphere, which is atmospheric pressure, plus the pressure due to the height of 10, which is density times g times 0.1. So the question is, at which position is the pressure greatest? So we notice that the pressure is greatest at this position here, at position B. So number 14, the answer is going to be B. In many filament lamps, as much as 92 joules of energy is emitted as thermal energy, so that is wasted. 80 joules is emitted as light. So it means total energy input is 92 plus 8, which is equal to 100 joules. That is total energy input. What is the efficiency of the filament lamp as the percentage of electrical energy converted to light? So efficiency is going to be equal to the energy output divided by the energy input. We want it as a percentage, so it is times 100. So this is going to be 8. That is output divided by input, which is 100 times 100, which gives us 80%. So question 15, our answer is going to be A. What is a unit for power? Remember, power is equal to work done over time taken, which is work done is in joules, time is in seconds. So joules divided by seconds, that is joules per second. So the answer is D. An object is in a uniform gravitational field. The graph shows how the change in gravitational potential delta EP of the object varies with the vertical distance x moved by the object. Which graph shows how the gravitational force F acting on the object varies with distance x. So of course, here the answer is simply going to be C without even hesitation, because the gravitational force, the gravitational force is depending on the mass of the Earth, not the mass of this object here. So the gravitational force, which is of course the same as the weight, this is the same as the weight, which is equal to m times g, where m is the mass of the object, which is not changing, and g is acceleration due to gravity, which is depending on the what, which is depending on the Earth. So it means the gravitational force is going to be a constant, because they said the graph shows how the change in the gravitational potential energy of the object varies with the vertical distance x moved by the object. So unless x is big, is very, very big, because of course the gravitational potential energy is equal to mg times x, where x is going to be the distance moved. But this one, mg is a constant, and mg is the gravitational force, so it remains constant. So the answer is C. A block of mass 2.0 kilograms is released from rest on a slope. It travels 7.0 meters down the slope and falls a vertical distance of 3 meters. The block experiences a frictional force parallel to the slope of 5 newtons. So friction must be upwards, 5.0 newtons, because it is moving downwards. What is the speed of the block after falling this distance? So we are going to use two methods. We can use conservation of energy, or we can use equations of motion. I expect that both of them are going to give us the same thing: conservation of energy or equations of motion. So if I use conservation of energy, I will say the loss in gravitational potential energy should be equal to the gain in kinetic energy. But because there's a friction, there will be work done against friction, so plus the work done against friction. So the loss in gravitational potential energy is going to be given by mg times the change in height h. The gain in kinetic energy is going to be a half. Let's say the kinetic energy here is a half mv squared, and the kinetic energy here is a half mu squared. But remember, it was initially at rest, so this one is initially 0. So the change is going to simply be a half mv squared plus the work done against friction is the frictional force times the distance moved, which is the distance moved in the direction of the frictional force, or parallel to the frictional force. So I'm just going to substitute. The mass is 2, g is 9.81, the vertical height is 3. This is going to be equal to a half times the mass, which is 2, times the speed, which is v squared, then plus the frictional force, which is 5 newtons, times the distance, which is going to be distance here, which is 7. So if I make v the subject, it means I'm going to say v squared equals to 2 times 9.81 times 3 minus 5 times 7. Then I multiply this, but of course the 2 cancels here. So I'll just find the square root to find v. So 2 times 9.81 times 3 minus 5 times 7. Then root of the answer. So that is 4.9 meters per second. So it means the answer is going to be A. That is using conservation of energy. Of course, I'm also going to use equations of motion, but of course, I'll need to find the acceleration. So if I try to find the acceleration, I will need a force which is acting downwards to move the mass downwards, which is going to be, I'm going to call this angle theta, and then sine of theta is going to be the opposite, which is 3 divided by the hypotenuse, which is 7. And the force which acts, the component of the weight, remember the weight is m times g, or 2 times g. The component of the weight which acts parallel to the plane is mg sine of theta. So the resultant force F, which is given by mass times acceleration, is going to be mg, which m is 2. So we'll say mg sine of theta minus the friction, which is 5. That is the resultant force. So the acceleration A is going to be m, which is 2, times g, which is 9.81, times sine theta, which is 3 over 7, then minus 5 divided by m, which is 2. So what is the acceleration here? So I have 2 times 9.81 times 3 divided by 7, then minus 5, then divide by 2. So the acceleration is 1.7. So the acceleration is 1.7 meters per second squared. That is the acceleration. Now that if we assume that there is no air resistance, then we assume that the acceleration is constant. So the equations of motion are now working. So I will use v squared equals to u squared plus 2as. That is just along the plane. So s is going to be the distance along the plane. So it means v is going to be the square root of, remember u is 0 because it was released from rest. So it is going to be 2 times 1.7 times 7, which is equal to, I think it is 4.9. 2 times 1.7 times 7. Then root of the answer, which is 4.9. So the answer is A. Two wires, one made of brass, one is made of brass, and the other of steel are stretched in an experiment. Both wires obey Hooke's law. So if they obey Hooke's law, then we can say force is directly proportional to extension, and the Young modulus for brass is less than the Young modulus for steel. So we know that Young modulus is equal to stress divided by strain. So if they obey Hooke's law, it also means the stress is directly proportional to strain. So that means it should be a straight line, because if they obey Hooke's law, stress, if force is directly proportional to strain to extension, then it also means stress should be directly proportional to strain. So if stress is directly proportional to strain, it means that the gradient should be Young modulus. So if a graph of stress against strain should be, first of all, a straight line, which means A is out, and C is out because the graph should be a straight line since stress is directly proportional to strain. And the gradient equals to Young modulus E. So the gradient of a stress against strain graph is Young modulus. So they said the Young modulus of one made of brass and the other is steel. The Young modulus of brass is less than. So E for brass is less than E for steel. So that means the gradient of brass should be less than the gradient of steel. The gradient of brass should be less than the gradient of steel because the Young modulus of brass is less than the Young modulus for steel. So it means the line for brass should be below that of steel to show that the gradient is less. So when you look at B and D, the answer is going to be B because for B, the line for brass is below, which shows a lower gradient compared to the line for steel. A sample of a material is stretched by a tensile force at a point beyond the elastic limit. It is beyond the elastic limit. The tensile force is then reduced to zero. Now that's the tensile force is reduced to zero. But since it was beyond the elastic limit, it means the extension does not go back to zero. Which area represents the net work done on the sample? Of course, when I add x plus y plus z, it means total area in loading or total work done in loading. When I look at z, z is the work which is returned. So it means the work which is not returned is going to be the net work done on the sample, which is going to be x plus y. So the net work done on the sample is going to be x plus y, which makes the answer to be B. X plus y is the net work done because x plus y plus z is the total work done in loading. Then z is the work done in unloading. So it means x plus y is the net work done because we have to remove whatever is returned on unloading. So the answer is going to be B. Then 21. A wire is fixed at one end and is extended by force F1 acting on the other end. This causes the wire to have an elastic potential energy of 0.15 joules. Let's first explore the formulas for elastic potential energy. So we know that elastic potential energy can be equal to a half times K times X squared, or it can be a half times F times X. Do not forget that F is equal to K times X. So because they have given us energy and the force, we have to eliminate X by all means because K is a constant. So it means the elastic potential energy is going to be equal to a half F. Where there is X, I'm going to put X equals to F over K. So this is going to be times F over K. So this means elastic potential energy is going to be F squared divided by 2K. So the force applied to the wire is now changed to F2. So when we have F1, energy is 0.15 equals to F1 squared divided by 2 times K. Then the force applied to the wire is now changed to F2. This causes the wire to have a new elastic potential energy of 0.6. So I'll say 0.6 is equal to F2 squared divided by 2K. So I just divide these two equations. We want the relationship between F2 and F1 or F1 and F2. So I can say as 0.6 divided by 0.15 is equal to, I'm dividing the two equations, is equal to F2 squared over 2K times the reciprocal, which is 2K over F1 squared. So 0.6 divided by 0.15, that is 4. So I have that 4 equals to F2 squared over F1 squared. When I find a square root, I have that f1, f2 over f1 is equal to 2 when I find a square root. So in other words, it means that f2 is equal to twice f1, or twice f1 is equal to f2. So the answer is going to be C. The diagram shows a representation of a wave on the screen of an oscilloscope. The Y gain is set to 3.5 millivolts per centimeter. What is the amplitude of the wave? So to find the amplitude, we need the representation of the amplitude. So we have 1, 2, 3, 4. The peak to peak is 4 divisions or 4 centimeters. So it means the amplitude representation is going to be equal to 2 centimeters. So to find the amplitude, we get the length representing the amplitude times the Y setting, which is going to be 2 centimeters times 3.5 millivolts per centimeter. So this one cancels, and this gives us 7.0 millivolts. So this means for question number 22, our answer is going to be C. A transverse wave, a transverse progressive wave on a string has a wavelength of 12 centimeters and an amplitude of 1.5 centimeters. The speed of the wave on the string is 48 centimeters per second. What is the distance traveled by a point on the string in a time of 2.0 seconds? So first of all, let's find the wavelength, or let's find the period first. So the period from V equals lambda times F, which is the same as lambda divided by T. It means that the period is going to be wavelength divided by V. So this is going to be the wavelength, which is 12 centimeters divided by V, which is 48 centimeters per second. So this gives us, of course, centimeters has cancelled. I think 12 divided by 48, that is a quarter, which is 0.25 seconds. Then, so that is the period. Then how many cycles are in 2 seconds? Because one cycle is 0.25 seconds. Then the number of cycles, is going to be 2.0 divided by 0.25. I think this is 8 cycles. So in 2.0 seconds, we have 8 cycles. So let's say this is one cycle. Okay. Remember, for a particle, it must, let's say this is the maximum point for the particle, and this is the minimum point for the particle, and this maximum displacement from the equilibrium position. This is equilibrium. So this maximum displacement is the amplitude, which is 1.5 centimeters. So let us say a particle starts from the highest, or let's say it starts from equilibrium. So it must move one time, that is a quarter cycle upwards, another quarter downwards, a quarter downwards below equilibrium, and then a quarter again back to equilibrium to complete one cycle. In other words, one cycle equals to 4 times the amplitude. That is the distance for one cycle. Distance moved for one cycle is 4 times the amplitude. But now the particle, after 2 seconds, the particle has moved 8 cycles. So total distance is going to be 8 times 4 times 1.5. So 8 times 4 times 1.5, which gives us 48. centimeters. So that means question number 23, the answer is going to be C. Remember, for one cycle, the particle moves through the vertical, it moves the amplitude 4 times. It goes up from equilibrium to the highest point, that is a quarter cycle, back to the equilibrium, that is a half a cycle, and it goes to the bottom part, that is another quarter, 3/4 now, back to equilibrium. That is now one full cycle. So the particle must, in one cycle, the particle moves the amplitude, the distance of the amplitude 4 times in one cycle. An ambulance siren emits a sound with a single frequency f. The ambulance travels towards, passes close to, and then travels away. Stationary observer. Which statement describes the frequency of the sound by the observer as the ambulance passes the observer? So remember, towards, the frequency is high, passes close to, and then travels away from a stationary observer. So the question is, which statement describes the frequency of the sound detected by the observer as the ambulance passes the observer? As the ambulance passes the observer, an ambulance siren emits a sound with a single frequency f. So here the answer is automatically going to be A, equal to f and decreasing, because if just passing, remember, when it's just approaching, the frequency is going to be equal to f. I mean greater than f. When as just passes, the frequency is going to be f, then it starts decreasing. Equal to f and increasing, it is not increasing when it continues. Greater than f and constant, when it's passing, it can't be greater than f. Less than f and constant, it is supposed to be because it must be starting to decrease, so it is equal to f and decreasing, so the answer is going to be A. Remember, as it's approaching, it is increasing, but when it's just passing the observer, when it just passes the observer, then it is equal to f and then it is decreasing. An electromagnetic wave has a wavelength of 138 picometers in a vacuum. To which region of the electromagnetic spectrum does this wave belong? So 138, I think this is the same as 138 times 10 to the power of minus 12 meters, which is 1.38 times 10 to the power of minus 10 meters, I think. And 10 to the power of 8, when you look at Reed's mother, is visiting Uncle Xavier's garden. Visible light on the left towards infrared, we have wavelength, which is red. Red is 7 times 10 to the power of minus 7 meters. This is red. The other side we have violet, which is 4 times 10 to the power of minus 7 meters. Minus 10 means the power of 10. We subtracted. When I subtract minus 2, I get 10 to the power of minus 9, which is approximately ultraviolet. 10 power minus 10 is approximately going to be X-rays, so the answer is going to be D, because remember, these wavelengths overlap. So the answer is D. That's why they did not even put here ultraviolet, because ultraviolet will also be a candidate, because these ones do what? They overlap. So minus 10 is going to be on the right-hand side of the visible spectrum. So the answer is D. A student investigates the polarization of waves. The microwaves from the transmitter are vertically polarized. A metal grill acts as a polarizing filter when placed between the microwave transmitter and the receiver. The reading on the voltmeter is proportional to the intensity. So let's say the reading on the voltmeter is V, and they are saying V is directly proportional to the intensity of the microwaves transmitted through. I want you to also remember intensity transmitted through is given by I naught cos squared of theta, where theta is the angle through which the axis of transmission has been moved from the vertical. So it means we shall now just modify this and say V equals to V naught cos squared theta. When the transmission axis of the grid is vertical, the voltmeter reads 3.50. When it is vertical, it means theta is 0. So when theta equals to 0, V equals to V naught, which is equal to 3.5 volts. The grid is then rotated through an angle theta. The voltmeter reads 2.5. So using the same equation, V is 2.20 volts is equal to V naught, which V naught is 3.5 cos squared of theta. So it means cos theta is going to be the square root of 2.2 divided by 3.5, and then theta equals to, so 2.2 divided by 3.5 under square root. Then I get the arc cos inverse of the answer, which is 37.5 degrees. So the cos inverse is 37.5 degrees. So the answer here is going to be A. Two waves superpose. A resultant wave pattern is formed. Which statement about the two waves must be correct? Two waves are superposed and the resultant wave pattern is formed. So if a resultant wave pattern is formed, the wave pattern is only formed if the waves are coherent and they have the same amplitude. So the answer is going to be, they have the same type, not necessarily the same amplitude, but of the same type. Which statement about the two waves must be correct? If they form a resultant wave pattern, then they must be of the same type. So I think the answer is going to be B. They have the same amplitude. Which statement about the two waves must be correct? Even if they have the same amplitude but they are not of the same type, we cannot see wave patterns. But if they have the same type, they have the same frequency, same wavelength, same amplitude, because they have the same type, they have the same speed, but they're just moving maybe in opposite directions, or they are moving the same direction, but they have the same type, then they are going to form what we call wave patterns. So both transverse and longitudinal can form wave patterns, so not necessarily transverse. Even if they are moving in the same direction, they can form wave patterns um, as long as they have the same type. So the answer is going to be B. A water wave passes through a gap in a harbor wall and diffracts. The gap has a width of 80 meters. The wave travels directly towards the gap. For which wavelength is the diffraction of the wave greatest? So that one is direct. The answer is 8 meters because diffraction is maximum when the wavelength is approximately the same as the size of the gap. If the size of the gap is much smaller, diffraction is less pronounced. If the size of the gap is much bigger than the wavelength, again, this diffraction is not well pronounced. So the answer is going to be D. Light of wavelength 5.5 times 10 to the power of minus 7 meters from a laser is instant normal on diffraction grating. The diffraction light is instant on a semicircular screen as shown in the view from above. The total of 9 bright dots are formed on the screen. So if this is the central, 9 means the total number is equal to twice n plus 1. So since the total number is 9, so this is going to be twice n plus 1, which means n is equal to 4. So we have 4, n equals to 4 at the bottom, and we have n equals to at the top plus n equals 0, which gives us 4 plus 1 plus 4, which gives us 9. So n should be 4. The grating is at the center of the same circle. The lines of the grating are vertical. The separation between adjacent lines is d. What is a possible value for d? So remember, for diffraction grating, n times lambda is equal to d sine of theta. Remember, we have seen n is not 9. 9 is total number of orders. We have 0 order, 1 first, second, third, upwards, up to the fourth. 0 order, first, second, third, and the fourth at the bottom. So n is the maximum order is 4 from the center. So n is 4. So we want to find this. So d is going to be n lambda divided by sine of theta, divided by sine of theta. But remember, when n equals to maximum, sine theta is equal to 1 because theta is going to be 90 degrees. So the maximum value of n is formed when theta is 90 degrees, even though here I've sketched it. The last order is going to be somewhere here. 4 should be there. So you have 3, you have 2, you have 1, you have the 0 order, and so on and so forth. So if n is maximum, then theta must be 90 degrees. Maybe let me resketch this. If n is maximum, we have the central order. The last order here, n maximum is going to be equal to 4 here, or n maximum is going to be 4 here. So this is 90 degrees because theta is measured from the center. This is n equals to 0. We can have n equals to 1, n equals to 2, n equals to 3, and so on and so forth. We can also have n equals to 1 here, n equals to 2, n equals to 3, until we reach n equals to 4. So it means d is going to be equal to 4 times the wavelength, which is 5.5 times 10 to the power of minus 7, which is equal to 5.5 times 4 exponent minus 7. So this is 2.2 times 10 to the power of minus 6. So the answer is going to be A. Of course, A is 2.25. Remember, when you are finding n must be a whole number, so you always round off. And when you round off, it affects the value of d if we are moving backwards. So, but this is the answer which is closest, so the answer is going to be A. Which quantity is given by the product of charge and electric potential difference? By the way, for question 29, you can prove backwards. You check these values to see which one gives you a whole number as 4. We can check backwards. So if we say n equals to d sine theta divided by lambda, n is going to be d, which we are taking 2.25 times 10 to the power of minus 6. Sine theta is going to be 1, divided by the wavelength, which is 5.50 times 10 to the power of minus 7. 2.25 exponent minus 6 divided by 5.5 exponent minus 7. So that gives us 4.09, and n must be a whole number, so n is equal to 4, which gives us a total of 4 plus 4 plus 1. So the answer is A. Which quantity is given by the product of charge and electric potential difference? So Q times V. Remember, potential difference is given as energy per unit charge. Energy transformed from electrical to thermal per unit charge, that is potential difference. So when I make E the subject, that is energy. So the answer is energy transferred, which is B. The current in the filament lamp is increased. So I is increased. Which statement about the lamp is correct? Which statement about the lamp is correct? So the brightness of the lamp decreases. So if the resistance is constant, then the PD is equal to I times R, and the PD is what determines the brightness. So the resistance is constant, the current has increased, the PD has increased, the brightness must increase. So A is wrong. Then the potential difference across the filament lamp decreases. When the current increases, potential difference increases. The resistance of the filament decreases. The current in a filament lamp is increased, and then we are saying the resistance decreases. If the current increases, the resistance decreases? Not at all. The temperature of the filament lamp increases. I think the answer is automatically diff. So for a filament lamp, as the current increases, the temperature is going to increase. That's now when the resistance will decrease. So the resistance will decrease after the temperature has increased to a greater value. So the answer is going to be D rather than C. Of course, C and D look to be almost correct, but it is D which leads to C. C cannot lead to D. So the answer is D. A student builds the circuit shown. The circuit shown, all the lamps are identical, so they have the same resistance. Which lamp dissipates the most power? So of course, the lamp which receives, because they are identical, they have the same resistance, let's say R. So it means the lamp which receives more current should dissipate more power, because power dissipated is equal to I squared times R. So the lamp which receives more current is going to dissipate more power, and it means the answer is going to be D, because all the current in the circuit, the current through this lamp here is going to be the total current which is flowing here. When it reaches this junction, part of it takes this path and part of it takes this path. So we know that I is equal to I1 plus I2. So it means the current going through D is more than the current going through A, B, and C. So it means the answer is going to be D, because it receives more current. So D receives more current. So it means it dissipates more power, because the resistance of each lamp is the same. And of course, the power dissipated in each lamp is going to be the current times the resistance. So since more current in D, then from power equals to I squared times R, it means more power. The resistance of a metal cube is measured by placing it between two parallel plates. The cube has volume V and is made of a metal wire, of a material with a resistivity rho. The connections to the cube have negligible resistance. Which expression gives the electrical resistance of the metal cube between X and Y? So we want electrical resistance. Okay. So we know that resistance equals to resistivity times L over cross-sectional area. And we also know that the volume of a cube is going to be side times side times side, which is going to be L cubed. And we know that the area is also going to be L squared. Cross-sectional area is L squared. So I am simply going to be, because the answers given here don't have L and they don't have A, so I'm going to remove A and I'm going to remove L. So you will notice that area, okay, I'm going to substitute here where there is L is going to be equal to V power 1 over 3. That is the cube root. Then where there is area, I know that area is also equal to volume divided by 1 length. Area is volume divided by 1 length. And remember, the length is V power a third. So the area can also be given as V divided by L, which is V power a third. So area, where there is area, I'm going to put there V. This is power 1. Power 1 divided by power third, that is 1. We subtract the powers. 1 minus a third, I think it becomes 2 over 3. So I'm now going to just substitute. So resistance is going to be equal to rho. Where there is L, I'm putting V power a third. Where there is area, I'm going to put V power 2 over 3. This is too much mathematics. So this is rho V. We add the powers. That is power a third plus. We subtract. So it is minus 2 over 3. So resistance is going to be rho times V. A third minus 2 over 3 becomes power negative 1 over 3, I think. And this is the same as rho divided by V power a third. When you take it at the bottom, the negative disappears, which makes the answer to be, I think it is C. A circuit needs to be completed by connecting two resistors between points X and Y as shown. The resistors can be connected in series or in parallel with each other. Which combination of resistors produces the least resistance between X and Y? Of course, the smallest resistances go to when resistors are in parallel. So we first eliminate in series, because in series we sum them up, because this will give us 60, this would give us 140. So we remain within parallel. Then resistors in parallel, total resistance in parallel can be got from the product over the sum. For the first one, we have 20 times 40 over 20 plus 40. For the second one, we have 40 times 100 over 40 plus 100. So the question is, which one gives us the least resistance? Which combination gives us the least resistance? And I think here the answer is automatically A, because this one is going to be, I can press my calculator, 20 times 40 divided by 60. So that is 13 point something. Then the other one is 40 times 100 divided by 140. That is around 29. So the answer is A. The diagram shows a circuit that includes a cell with internal resistance. So if a cell has internal resistance, there are lost volts here. And the lost volts is equal to the current, which is going to be I1 times the internal resistance R. The switch is initially open. Okay, so if the switch is initially open, in this case I1 is the same as I2. Which law describes the effect on currents I1 and I2 of closing the switch? So if the switch is closed, it means total resistance is going to be increased. If the switch is closed, total resistance is going to be total resistance here. These are going to be resistors in parallel, and total resistance of resistors in parallel is equal to a value smaller than the smallest resistor. So total resistance is going to be decreased. R total decreases, which means total current in the circuit, which is the same as I1, is going to decrease. Total current is always that current from the battery or through the battery. So I1 decreases. And if I1 decreases, it means the lost volts, which is I1 times R, lost volts are going to decrease. So the question is, which law describes the effect on currents R1? So I1, so no, I1 increases. Because total resistance decreases, I1 is equal to the EMF divided by R total. R total decreases, I1 increases. So I1 increases, doesn't decrease. Sorry about this. That means the other one is also not correct. Because the total resistance decreases and the current is equal to EMF over total resistance, so I1 increases. So I1, which is equal to I total, I1 increases. And if I1 increases, it means the lost volts is I1 times R, so lost volts increase. So the lost volts increase. So we know that I1 increases, so we eliminate A and B. Then we look at I2. What is going to determine I2? I2 is going to be the PD across, is going to be the terminal PDV divided by R2. Let me call this one R2. So what has happened to the terminal PD? The EMF, remember, is equal to the terminal PD plus the lost volts. But making V the substitute, V is equal to the EMF minus the lost volts. The lost volts have increased. So it means when I subtract, the difference becomes smaller. So V has decreased. And if V has decreased without R2 changing, it means I2 has decreased. So I2 decreases. So the answer is C. If the terminal PD or the PD across this parallel circuit has decreased, which is the terminal PD, and the current I2 is equal to the terminal PD divided by the resistance. If the terminal PD has become smaller, so I2 has decreased. So the answer is C. The diagram shows a circuit consisting of a cell and three resistors R1, R2, and R3. The cell has EMF 1.6 and negligible internal resistance. The current in the cell is 0.64. The PD across R1 is 0.48. The current in R3 is 0.32. So if the current here is 0.32, it means the current here is going to be 0.6 minus 0.32. So the current here is 0.32 amperes, because by Kirchhoff's first law, the sum of the current entering the junction is equal to the sum of the current leaving the junction. So what is the resistance of R2? So I just need the PD here, which is going to be, because the PD between these 2 points is going to be the same as the EMF, because the cell has negligible internal resistance. So this is going to be 1.6 minus 0.48. So this PD is going to be 1.6 minus 0.48. The PD across R2 is 1.12 volts. So if I want the resistance R2, it is going to be the PDV divided by the current. So the PD is 1.12 and the current is 0.32. Which gives us 3.5. So this is 3.5 ohms. So the answer is C. The diagram shows a potentiometer circuit used to compare EMF E1 and E2 of two cells. XY is a uniform resistance wire. The fixed resistor has resistance R. A sliding contact is moved along the wire XY. When the sliding contact is at point P, the galvanometer reads 0. So when the galvanometer reads 0, it means the PD across XP is the same as the EMF. And assuming the cell has negligible internal resistance, its EMF must be constant. So the circuit is changed so that the galvanometer reads 0 when the sliding contact is at a new position to the left of P. So it's like they are saying this is to the left of P. So something must be done here because EMF E2 must remain constant. So let's first see what is E2. The EMF E2 is always going to be the PD across XP. And the PD across XP depends on the length and the PD per centimeter here. So there is a constant which we call the PD per centimeter. We call the constant K, which is going to be the PD across x, y divided by the length x, y. So it means if I want only the PD for xp, this is going to be the length xp times the PD across xy over lxy. So this is going to be a constant. Unless, and that constant can only be affected if E1 is changed. Okay, so it means E2 must always be equal to the length LXP times PD across XY over the length XY. Okay, so let's inspect the answers now. Which change could have been made to the circuit? Remember, the reading becomes 0 when the sliding contact is moved to the left. Which change must give us a value E2 when we move to the left? Remember, E2 must remain constant. E2 must remain the EMF of the cell because the EMF must be constant. So if we have to move to the left to give us the same value E2, then something must have happened across XY. So let's see, the wire XY was replaced with one of lower resistance. Lower resistance means if resistance of XY is decreased, it means the PD across XY has decreased because the PD across XY depends on the current and the resistance. So the PD across XY has reduced, it decreases, which would mean LXP must increase to give us this equation here, which would require to increase the length xp. So this would mean moving to the right. In other words, moving to the right. Yet we have moved to the left, so this one is out. Then E2 was increased. Which change could have been made? Of course, we cannot increase E2. But even if we were to increase E2, let's inspect this. If E2 is increased, then it means the PD across XP must be bigger than before. So it has been increased. The PD across XP must be increased. And remember, the PD across XP and the PD across XP is directly proportional to the length of XP. So if VP must become bigger, then LXP must also be bigger, which also requires moving to so LXP, L is standing for length, LXP must be increased, which means I'm moving to the right again. That would mean moving to the right. Let's check E1. E1 being decreased. If E1 is decreased, what happens to the PD across XY? Because if E1 is decreased, remember, E1 is the PD across R plus the PD across XP. E1 is equal to the PD across R plus the PD across XY, not XP. So if E1 is decreased, it means, of course, if the resistance has not changed here and R and this has not changed, means the current is going to be decreased. If the current is decreased, it means the PD across R decreases and the PD across XY also decreases. So if E1 is decreased, it means the PD across XY has decreased. And if the PD across XY has decreased, Remember, the EMF E2 must remain constant. So it means the quantity Vxy divided by L xp, this quantity here in the equation which I wrote above, has decreased. And remember, E2 is equal to the length xp times Vxy over Lx. No, this is Lxy, not Lxp. Lxy, where Lxy is the length of the whole wire. Because this quantity has decreased, yet this should remain constant, this must be increased. So we can't, Lx cannot be increased by moving to the left. It increases by moving to the right. So for E2 to be equal to that, since Vxy over Lxy has decreased, then Lxp must increase, which would require moving to the right. This means moving to the right again. So it means these ones are not correct. So the answer must be D. Let's see how D is correct. If R is reduced, what does that mean? If the EMF E1 remains constant, it means the PD across R has reduced. Remember, the EMF E has remained constant. R1, the PD across R has decreased. EMF E1 has remained constant. It means this should increase to balance because the sum should be equal to E1. So the PD across R1 has decreased. And remember, E1 is equal to PD across R1 plus the PD across XY. When this decreases, this must increase. So it means the PD across XY has increased. So for E2 to remain the same, since E2 is equal to L XP into the PD across XY over the length XY. Remember, this is a calibration constant. Because this one has increased, for E2 to remain the same, this should be decreased. So for E2 to remain the same, Lxp must decrease, hence movement to the left. So the answer is going to be D. Okay, I've taken more time because I give a lot of explanation. Nevertheless, I'm almost done. Nucleus P has 144 neutrons and 92 protons. So nucleus P must be here. 144, okay. P is unstable and undergoes alpha decay. It undergoes alpha decay. So P, which is 93, 144, gives us another nucleus which is called Q plus an alpha particle which is 42. So this becomes 91, 140. So Q must be 91, 140. So this is where we have Q. Then Q undergoes beta minus decay. So Q, which is 140, 91, undergoes a beta minus decay, which is 0, -1, to give us R. So this remains 140. That remains 140. Then the proton number becomes nucleus Q. This becomes 92. So nucleus P is represented by P on the graph. Which point on the graph represents, wait a minute. I think what is given here is number of neutrons, not nucleon number. Sorry. So neutron number, so I have to change this. what is given, that's why the Cambridge examiner is very intelligent. What is given is number of neutrons, not number of nucleons. So here, for P, number of nucleons, P is going to be written as 93, and then 144 plus 93. So this is 237. So 237 gives us Q plus alpha, which is 42. So when I subtract, this is 233, and this is 92. Then Q gives us R. So Q, which is 233, 92, gives us R plus beta minus, which is beta 0, -1. So this is going to be 90. Sorry, this was 91. This is 91. So this becomes 92. Then the nucleon number remains 233. Then number of neutrons is 233 minus 92. 233 minus 92, which is 141. So number of protons is 92, number of neutrons is 141. So the answer is A. The diagram shows the quark composition of 4 different hadrons. One of the hadron is epsilon plus particle. It has a charge of positive E, where E is the elementary charge. Which hadron could be epsilon plus particle? So remember, a down quark has a charge of -1/3e, same as strange. Strange and down have that charge. Then up has a charge of plus 2/3e. So we are just going to check the charges here. So for A, what is the charge? For A, the charge is going to be -1/3 times 2, actually times 3. This one is -1/3 e times 3, which is equal to -e. So this is out. This one is also down strange. So this is -1/3 e times 3, because each has -3. So this is -e, which is out. And this is plus 2/3 e, then plus 2 times -1/3 e. So this gives us, I think this gives us 0. So this is out. So the answer must be D. So 39, I think the answer is going to be D, because up, there are 2 up, so it is 2 times 2/3e, then plus strange, which is -1/3e, which is 4/3 plus minus 1/3, which gives us 3e over 3, which is equal to positive e. So the answer is D. Which type of particle is comprised of the most quarks? So an antiquark is just an antiquark. But leptons have no quarks. A meson is made up of a quark and an antiquark, and a quark. So a baryon is either a proton or a neutron. A baryon has up, down. A neutron has up, down, down. So the answer here is going to be B, most quarks. So the answer is B. I think that is the end of the multiple choice questions. I've solved them all the papers 1, 1, 1, 2, and 1, 3. Until next time, bye bye.